Hi everyone, I thought it would be fun to do a remote imaging session using Chilescope. I'm in Canada, and Chilescope obviously is in Chile, so 8,000 miles away. It's quite a distance, but it's cool that we can do this. Time zone is about an hour difference. We just hit daylight savings times today, so I think Chile is where Chilescope is located is 1 hour ahead. I'll check that in a minute. This should be interesting. I'm not unfamiliar with remote imaging. I've been doing it for years with my partner and collaborator, Paul Mortfield from Sierra Remote Observatories in California. I've had that going for now about a decade, but you know, can't get those southern targets, and there's some really amazing stuff down there. Not that I'm totally familiar with it. That's actually one of the problems, or one of the challenges that I face is starting this kind of a project. But you know, that's part of the fun, the discovery, the exploration of the kind of stuff that's there. I've done some research on Google, found a couple of imagers that have some great shots from Chile or Australia, southern hemisphere targets anyways, and I think I found an area that I'd like to image. There are the obvious ones like the Tarantula Nebula and Omega Centauri, and the LMC, the Large Magellanic Cloud, but that's 10 degrees wide, and even with the big field of view that we have with the equipment, the gear from Chilescope, still not enough. Yet, I really like the LMC, and I think I'm going to try and target a couple of areas in there and see which ones I like the best. So the first thing I'm going to do is schedule a session to run a couple of subs, a couple of light frames on two areas in and around the Large Magellanic Cloud, and then review them and do the final run soon. Now, I'm also running out of time here. It's getting lower and lower in the sky. Really can't image past 1:30 a.m. local time in Chile because the target dips below 30 degrees. I mean, right now, I can't start too early in the evening because of daylight, but just this time of the year, we're really at the very end of it. So if I'm gonna get it done, I gotta get it done now. So let's move over here and sign in. I'm signed in here on Chilescope. And I'm going to go to the members area here, sessions and plans, and I've got a couple of sessions already in here, but I'll show you how this is done. So let that come up, and I see I have LMC test, and that's going to run this evening, a 1 hour session, 3 10-minute subs of each of two different areas. And the areas I picked, I use Starry Night Pro Plus for this kind of stuff. During the actual imaging, when I do my own imaging sessions, either from here in Toronto in my driveway, my backyard, or remotely, I basically use the Sky 6, an older version, to do the setup, the planning, and as an ASCOM hub, Maxim DL, Focus Max, and CCDAP is my automation software of choice these days. Has been for many years. I've tried a couple of the other ones too. But that one I'm comfortable with, and I really like it. So this is much simpler to get going than your own remote setup. It's pretty automated. You basically just have to give it the target, the coordinates of where you want to point the scope, and the type of light frames that you're looking for. So here, let me show you what I picked. All right. So in Starry Night Pro Plus, there are two areas, and I have them designated here by this little dot. This field of view indicator is basically the size of the chip with the scope that they have at Chilescope, the ones that I'm interested in. There's two telescopes that are identical. So they're 500 millimeter, half meter astrographs, Newtonian, the ASA ones, at f3.6. The focal length is 1800 millimeters, very fast scope. So I expect to go pretty deep in not very much time. So the first target, I like this area here. I mean, the Tarantula Nebula fits in perfectly in this field of view, as you can see. But this is kind of cool. I'm not sure exactly what it'll look like, so this is why I'm going to do the 3 test shots. The other part that I kind of am digging is this area here in around NGC 2004. Actually, that's 2004 up there. NGC 2032, which is here. But there's a cluster of them. And why I like this one here is because there's this blue cloud of stars in this region, and some dark skies or some dark empty space in behind it. So it might make for an interesting composition, some kind of a dramatic look. So, and I'm looking for that kind of thing. So that's one, and this is the other. So I need to determine exactly when's the best time to shoot these. One of the cool things, I'll just shut down here, is this graph view down here along the bottom of the screen for Starry Night Pro, and it basically plots the movement, the altitude of various objects that I can throw down here, and I put in this first one here, and I can see that it transits right around this hour here, which is before sunset, and so that's no good. Also, I know that sunset this evening is, let me take a quick look. It's going to be sunset, where are they? 8:06 p.m. You really don't want to start imaging before the sun is 18 degrees below the horizon. So that's about an hour and a half to 2 hours after sunset. That is a good time when you know that your skies are as dark as they're going to get. I'm just going to center it right on that target. This is the field of view that I'd like. So around there, I'm going to select center on those coordinates. And now when I move it, I can actually see how it moves in elevation. And I can see at this point, 11:34, 10 p.m., it's at 49 degrees above. This is an Altaz grid I have overlaid on the Starry Night Pro. And I got to stop before it gets to 30 degrees above. So if I move forward here in time, and that is going to happen approximately 30 degrees right here, about 1:22 a.m., 1:23 a.m. in the morning. So that's about 3 hours of imaging time. I'm just going to shoot 1 hour tonight, but in a couple of days, I'm going to do the rest of all the subframes after I inspect the frames that I get from tonight's imaging session. So now that I have that, let's go back here to Starry Night Pro Plus and let's look at my test. I have a 1 hour session. And here it comes. So here it is. It's in blue. It's sailing from this point here, the darker blue, that is my imaging run. The lighter blue stuff is technical operations. They don't charge you for this. You only get charged the portion that's in blue, the dark blue area. The technical stuff is what they account for requiring things like slewing the telescope, refocusing, doing plate solves, and acquiring a guide star and dithering and everything else that happens in between. So there's probably about an hour and a half here allocated time for 1 hour of imaging time, half an hour for technical time. 40 to 60% is what they say is basically normal of your observing time. And it depends on the number of filter changes, how many times you're moving to different targets. So on this one here, I have two various plans for this observing session. I'll just open them up. It takes a second. I've given a name of NGC 2032. So that's the first target that I want to inspect, which is basically on Starry Night Pro Plus. It's this part of the field right here. That's the one. I'm going to take 3 shots, unbin luminance of that area, and then have a look a little bit later. So the second target that I'd like to inspect is where I've labeled it LMC core. If I center my field of view on there, this is the second one. And if I go back to the Chilescope here, and we see plan number 2 is the LMC core, and these are the coordinates for that. And the way I get the coordinates from Starry Night Pro, I want to be precise about this, right, is I've set up field of view indicators, and this is one of the things that bugs me with Starry Night, and why I use the sky for actual imaging sessions. While Starry Night has this really great all-sky mosaic for you to check around and view, some things that really kind of drive me crazy when I'm like, for example, I need to know this field of view indicator for this the telescope and CCD camera combination, which I've labeled U16M as for the apogee just because I'm used to that camera. In actual fact, they're using a Proline 16803 camera, the same chip, virtually the identical type of performance from both cameras. Although Apogee and Proline will disagree with you, but anyways, they're both fantastic cameras. So I look at the LMC core, and I have actually a field of view indicator that I've enabled that. If I go up here in the corner and I click it and select edit, then it's going to give me the coordinates. So for example, I'll give you another example. Say I wanted to image the Tarantula Nebula here, and this is basically the field of view. This is what I want to capture. I want the telescope and my field of view to be exactly this. So I can hover over that point there. It's not really showing me what I need to know. But if I right click right there and I select add a field of view indicator, I'm just going to put a circular one in there, and I'm going to say it's 0.5 degrees. That's kind of big, so let's go 0.05 degrees. The color, okay, let's go with bright orange, that one, and I'm gonna call it Tarantula, and positioning is RA and deck, as opposed to relative to the screen center or RA deck. That's going to give me the exact coordinates. I mean, it's showing me right here what it is, but I'll press OK, and as you can see, it's put it in the wrong spot. It's put it right on the Tarantula Nebula. So I'm just going to remove this and delete that. Again, let me just center this and give this one more shot. Let's zoom in here. I want a field of view indicator right here. Add a field of view indicator, circular, and 0.05. I'll just leave it untitled for now. And again, it keeps marking the tarantula. Boy, what a pain this is. Okay, so I have my field of view indicators there, back in Chilescope. So if I go back to this area, I find the coordinates that I need, and you see 2032 is the name of the field indicator. I look here, and I can just copy and paste, or just copy these values into the new target. So at Chilescope, I have entered the coordinates for the first target. That's under plan 1, showing me that this is a target name. These are my coordinates. I'm going to refocus every 60 minutes, although I don't need to. I'm going to have it auto guide and have it decide on the dithering by putting in a value of minus 1.0. You can put in your own value here. I'm not going to get into what dithering is. It's really important, though. I mean, it helps a lot. So I highly recommend that you use dithering, even though it takes a bit of extra time. Remember, you don't pay for the technical time. That's just added on as a courtesy by Chilescope. You only pay for the actual exposure observing time that you do. So here we have, I want 3, and I want luminance, 600 seconds for plan number 1, plan number 2. Let's see what we have under plan number 2. Once again, it's should basically be 1 megahertz. Again, I want not red. I want luminance. Luminance here, luminance there, luminance everywhere. Save the session, and we'll wait. If it gives us an error, we'll see it up here. And no errors, because it would show up in red if there was anything amiss here, and including limits for observing time. So there we have it. It's going to go tonight at, we have it set for 10:50 p.m. And 1 hour of data as you grab 30 minutes each of each one of those 2 targets. And we'll check back in a little bit. Maybe this evening we'll see how it's doing. But for sure, in the morning I should have an email saying, "Hey, your target's done. Your data is ready for you to download." Patience. And more patience. Anyways, we'll check back a little bit later. Tonight, it's going to be kind of late. 9 p.m. my time. That's not so bad. The imaging run with all the technical time added onto the end is probably going to finish around, I think, about 12:30 Chilean time, which is 11:30 my time. So we'll have a look. But and see what's available, and maybe bring it down and do a quick calibration and check it out. Okay. Okay, hi, I'm back. I just received a notice through email that the session is underway, the one that we planned earlier this afternoon. It is now 11:12 local time here in Toronto. So let's take a look. Oh my goodness, look. You see this? There's actually some data here. All right. It's showing me a JPEG, and this definitely looks like the LMC core. We need flat files here, obviously, because the edges are, these are uncalibrated frames. Still, pretty cool. Looks kind of interesting. Oh, these little pieces here, and I really love the entire field filled up with this fine, sugary stardust. Well, they're stars, but you know, it's a galaxy, so there's hundreds of billions of stars here. And now look at that. I think it's going to be pretty incredible when I actually get the data files. So, you know, while I'm here, let's have a look at the, if I look at the weather conditions of what they are currently. Here it is. So cloud sensor data, let's have a look there. Here it is. 6 seconds ago, it is 16.73 degrees Celsius. It's clear, it's dry, it's dark. And status, switch is open, which I believe means it's actually running. And look a little further down. And I believe one of these lines is showing the previous day. Is it this one here? Show yesterday? Yeah, right. So this is the actual data at this very moment. Okay. Usually when you see the temperature go up, that means there's clouds. But it's saying it's clear. So let's look at the all-sky camera. Oh, there it is. Okay, so take a closer look. Now there's the LMC. See how low it's getting already? It's getting into the super. That looks like some clouds on the horizon. Obviously, you can see the Milky Way. There's Orion. There's the LMC. Yeah, you know, let's have a look at Starry Night. Okay, so the time here is 3:16 UTC. South. Here's the LMC. It's showing me a bunch of extra targets in here. There's the LMC. There's the Milky Way. Orion is up here. Orion is over here. So it seems to match up. I'm pretty confident that, just looking at it visually, that this is the actual time. We should play this at normal sidereal rate. So let's go now again. Okay, anyway, so there we have it. I'll check back tomorrow morning, and I'll continue this video when I have something to show you, and I'll download them. I'll quickly bring them into either PixInsight or MaxMDL, just so that we can preview what's there, and see where we go. Hopefully we'll have the second target as well, and then I'll make a decision which one to go with. Since I already have time booked ahead in the next few days, I can always change the coordinates on that session that I booked once I decide definitively which of those two areas of the Large Magellanic Cloud that I'd like to continue with. This one I'm seeing now looks pretty interesting. I don't think I've done an image where the entire field is the middle of a galaxy and there's no space, there's no dark areas around it. So it's going to be completely peppered with stars and punctuated with some of those interesting NGC objects in there, those brighter NGC objects, which I believe are mostly emission from H alpha. So who knows, I might have to add some H-alpha data to this as well. But that's the nice thing about this. As you go along, it's not like you need to grab everything at once. And, you know, you play it by ear, and you improv, and you adapt, and you move forward. So it's still fun. Yeah, I'm hoping that what we get back and what we see is just going to be incredible. I have no doubt. I mean, I know these people. They're really quite at the top of their game. They don't take anything to chance, and they don't leave anything to chance, I should say. And this entire installation of Chilescope is so meticulously and well planned and thought out. The studies that they spent a long time picking the right location with good seeing, and it's not just enough to have dark skies and clear skies. I mean, the seeing has to be impeccable, or else, you know, you're not really taking full advantage of the resolution that's available to you. So, I'll be right back as soon as I have something to show you. Okay, I'm back. It's actually 2 days later now. I received notice yesterday that my data was ready for me to download, but I really didn't have that much time to come in and record the session. So I'm doing it today. I really haven't done anything except inspect it, but I'm going to show you. And I think you're going to be pretty impressed with what you see. I was really happy when I got the results. But let's take a look. Excuse me, let me take a look at my files. And here is the folder that contains the light frames that were shot 2 nights ago. So there they are, all the individual FITS files are there, so I can download them, and I've already taken the liberty of doing that. So we'll have a look. Let's just have a look what we have, okay? Here are my files. I've already taken a look at them. So let's look at NGC 2032, that first field that I showed you. And double click it, and it's going to come up in Maxim. Here it is. We don't see very much. I have to stretch it, so I'm going to apply a DDP to it very quickly just to see what we have. Okay, these are calibrated. I've already taken the liberty of calibrating these. Let's go auto, and whoa, that's pretty special. So let me just drop the black point here a bit. Okay, this is good. So here, insane. Look at this. This is a single 10-minute subframe binned on that telescope. And just look at how clean and how deep this goes. Let me just zoom out a bit here so you can see the entire field. I mean, that's crazy. That's insane. Look at this. This is beautiful. I can't believe it. One single 10-minute subframe. Well, this is what you get when you get these really fast scopes. Pristine dark skies, rarefied air. I mean, this is going to be a joy to work with. I tell you right now, this is going to be incredible. So, so just to see, like, you know, remember what I needed to get exact targeting, and I wasn't really sure how it was going to come out, and I was, you know, I had the field of view indicators in Starry Night Pro, but so let's compare what I have here and what I had planned the previous night. Still have the field of view indicator. It's called Starry Night Up, and here it is. There's the actual target, and let's center it on the screen. And sure enough, you can see here that this is pretty close. I mean, that's pretty much exactly what I had calculated it to be, or at least Starry Night is. I just got to put in the correct parameters. And if I look at the actual data itself, and this is giving me a bit of a hard time here. Why is that? So, as you can see, it's identical. The field of view, that single 10-minute shot, is identical to what I've set up in Starry Night as a field of view indicator. And this is what I used to enter the coordinates in Chilescope as well. So that's pretty spectacular. Now, what about the second target, the LMC core? How does that look? Well, let's take a look at that. The LMC core, again, I've taken the liberty of calibrating this already. I've downloaded the calibration files from Chilescope, and I just ran a pass on each one of these luminance frames. And I'm going to do the same kind of a stretch. I'm going to use DDP in Maxim DL. Digital development. I have a very quick way of doing this. I'm just going to select auto, and then I basically back off on until I see a little bit of room here on the left side of the histogram. So 1200 is too high. Let's back that down to 1000. And that gives me enough space, maybe a little higher. But anyways, I'm okay with this. So let's zoom out. And again, it's just insane. The signal to noise ratio, just the amount of signal and the beauty. There are no light leaks. There are no internal reflections. The field is completely flat. I mean, it drops off on the edge here because this is the core of the LMC, and that's normal. And as a matter of fact, let's do the same thing. Let's go into Starry Night and find that same field of view. Here it is, the LMC core, and we take a look at what Starry Night has indicated that it's going to shoot, and we compare it to what the actual test data from that evening. And as you can see, it's identical. So I'd love to be able to do both of these targets because, I mean, they just look spectacular, but I have to pick one. Just don't have enough time before this area of the sky of the LMC drops below that 30 degree above the horizon in elevation, in altitude, I should say. But I think for this time, I'm going to go for this field here. It just looks kind of dramatic, and I think it's going to turn out amazing. I think both of them will. I'll save the other one for next season when the LMC gets into better, maybe in 6 months' time, when it starts to rise on the other side. So here it is. We're going to shoot this. And I think, I've been thinking about this because I've had this data now for a day. Typically, I'd like to do 7 or 8 hours on any kind of a target, but after seeing this single frame here, I think I can get away with 4 hours of LRGB unbinned. Basically, I'm going to do 1 hour of luminance data, 1 hour of red, green, and blue each. And in the end, I'm going to use PixInsight to create a super luminance layer that's going to take the luminance plus the RGB and create a super luminance frame, so even better. But I just can't imagine, after seeing one single frame like this, an hour of luminance of this quality data, it's just, yeah, it's going to crush it. I'm so excited about how this is going to turn out. I hope I'm not setting myself up for any disappointment if I mess it up in the processing. I hope I don't, but I'm pretty stubborn when it comes to these things. If I don't get it right, I just keep at it and I keep at it and I keep at it like a bulldog with a bone. I just won't let go until I won't rest until it's absolutely to my satisfaction. So it looks incredible. Now I've gone ahead and I've scheduled the coming sessions. I'll show you what I've done on Chilescope. Okay. So I've got 2 observing sessions on the 14th, which is tomorrow evening. I have 2 hours and 40 minutes. And the following evening on the 15th, I have 2 hours and 40 minutes. I have them labeled 2032 LNR, meaning I'm going to be shooting luminance for 1 hour and red for an hour. On the following evening, I'm going to be shooting blue for an hour and green for an hour. And there's actually a method to my madness here as far as the order of why I'm shooting the filters in the order that they are. I'll open it up and we can have a look. Okay, here are my sessions. So I've also learned a couple of things in the past couple of days. The available time, the first slot available says 9:12 p.m. That means that's the point where astronomical twilight is done and it's fully dark. So I can schedule my session exactly at 9:12 if there's time available. I've got 2 hours and 40 minutes in there because even though I have 2 hours of data, remember there's a technical stuff that needs to happen, the technical portion of that gets mixed in with the rest of your imaging session. Things like, slewing to the target, doing place saws, focusing, changing filters, dithering, everything else that ends up happening in order to get the session, the entire length of the session. So 2 hours and 40 minutes ought to do it. I'm hoping it should do it. Okay, so I'm interrupting this video just for a minute here to clarify a point. As you've seen, I've been putting in extended observing times. So Those 2-hour observing sessions, I've entered a total session time of 2 hours and 40 minutes. That's not necessary. Chilescope will automatically tack on the additional technical time that you need based on the total exposure time and all the plans that you have in that session. So all the exposure times I had in there were for 2 hours. All I needed to do was plan a session and give the duration of 2 hours. Chilescope would have tacked on an additional 50% onto the end of that. So I didn't need to do that extra 40 minutes or so to try and fudge it. It was not necessary. The only thing you got to keep in mind is that it will add that additional 50% of time onto your observing session by adding up all the exposures inside of every plan that you have within that session. That means if you had thought that, well, I've got 2 hours of observing time that I can start 2 hours before sunrise or before 2 hours of astronomical twilight begins in the morning, well, keep in mind that it's going to be longer than you think. Take that into account, but don't actually enter a session longer than you really are looking for in total exposure time. Okay, I hope that clears it up. So when you see me mentioning that in the video, ignore it. It's not necessary. I wanted 2 hours of data. All I needed to do was plug in 2 hours for the duration of the session. Let's open up the plan and see what I've done here. I've got the coordinates, which are identical to what I used the other night. 6 luminous frames, 600 seconds each, which is 10 minutes, unbinned. 6 red. So you're wondering, oh, so why the red? I mean, I could have picked any filter to go in here. But the thing is that at that point, I'm expecting this target to be lower in the sky, probably around 38 degrees or so. And by shooting red this later, when the target is lower, I don't have to worry about red extinction. If I were to use blue, then I know I'm not going to get as much signal because it's going through a lot more atmosphere, and the blue signal is going to be attenuated, only because of the time and how low the target is in the sky. So 1 hour of luminance, 1 hour of red. Now I'm counting on the following night to have a clear night as well and everything to go okay. And those nights I'm going to be shooting blue and green. And let's go to that session. And a second night here, and I've labeled it 2032 BG for 2032 blue and green. So in this case, I start with blue and then I move to green. Again, I'm starting with blue because early in the evening, this is when it's the highest in altitude in the sky. And again, the issue is blue extinction. The lower the target gets on the horizon, the more atmosphere it goes through, the more blue light is absorbed by the atmosphere. So by doing the blue filter first when it's highest in the sky, followed by green, which is not as affected by blue, and red is the least affected by, is not as affected by the red extinction, but still there is some. The longer the wavelength, the more it will penetrate the atmosphere. The shorter wavelengths get sucked up and absorbed by more atmosphere. So we're going to do blue first, green second, an hour of each. And hopefully that'll give me the 4 hours that I need to complete this target. I hope you've seen how simple it is to actually set up a remote imaging session from Chilescope. It's quite a treat to have access to these southern targets and to be able to do it from such a pristine location. I mean, just the best location you can think of for doing astrophotography, as you saw from that one single frame. All right, so I have links to below Chilescope if you're interested, and if you enjoyed this and want to be informed of the next coming on, where I grab all the data and we do some process it and see what we end up getting. Subscribe. Like the video, that would help a lot. Like I said, we're just getting started here, but we're going to do some cool things, not just processing tutorials, but things like animation of still astrophotos, which is kind of a fun area that I've been exploring. I have been for quite a while, both in Premiere and maybe doing some parallax 2.5D stuff in After Effects, which I've dabbled in before. Thank you for watching. I hope you enjoyed it, and hope to see you soon.